Student, now again there is a GOC lecture 4. Okay, now the topic is mesomeric effect and or resonance effect. Maximum there is a mesomeric effect or resonance effects are same. Okay, but there is a small difference between these two effects. These effects, mesomeric and resonance. In this case, there is a conjugation is very important. You know conjugation. There is a pi sigma lone pair. Pi sigma positive, pi sigma free radical and lone pair sigma positive. There is a 5 conjugation. So now this is very small difference between mesomeric and resonance effect. So just check. There is a formula CH2 double bond CS single bond CH double bond CH2 and single bond OH. Now in this case, you know oxygen has lone pair of electron. Okay, so now there is a pi sigma pi conjugation and pi sigma lone pair. So if the atom have lone pair of electron, so it easily donate electron to this carbon. So there is a formation of double bond and oxygen contain positive charge. So it means there is a, in this case there is a valency of carbon is 5. So now this carbon again donate this electron to this carbon, same for this. So now if the atom have lone pair of electron, it means electron donate through resonance. And this type of effect is known as plus M effect. Now in this case there is a electron donating group. So EDG group is there. The EDG group is there, it means definitely plus M effect is there. Now the same CH2 double bond CS single bond CH double bond CH2 single bond and double bond O and coordinate bond O. This is a formula of NO2 group. So now in this case oxygen, you know very well, nitrogen and oxygen, which is more electronegative, oxygen. So oxygen attract the electron from the nitrogen. So now in this case electron withdrawing group is there. Electron withdrawing, na? In this case oxygen withdraw electron from the nitrogen. So electron withdraw through resonance, and this type of effect is known as resonance. Now the difference between mesomeric and resonance. Okay. Now if any atom or group donates electron withdraw through resonance are called mesomeric effect. Okay. Now in this case देखो, there is a oxygen and there is a nitrogen. So there is a different atom, oxygen and nitrogen, there is no carbon. If carbon is there, it means resonance. If other atom is there, so definitely it means mesomeric effect. So there is a electron donating group. The electron donating group is there, it means plus M effect. Electron withdrawing group is there, it means minus M effect. Okay, clear? Okay. Now all mesomeric effects are resonance effect. All, just you note down in your notebook, all mesomeric effect are resonance effect, but all resonance effect are not mesomeric effect. Clear? Now, so now in the case of benzene ring, so these are the example. देखो, chlorine has lone pair of electron, so this plus M effect. Oxygen has lone pair, nitrogen has lone pair. This is anisole has lone pair, nitrogen has lone pair. So these type of effect is plus M effect. And now in this case, देखो, oxygen is a more electronegative, so it withdraw the electron from the nitrogen, so this is minus M effect. Again carbon and oxygen is more electronegative, again this is, yeah, so these example of minus M effect. Now how to explain ki plus M effect is what and minus M effect is what? So plus M effect, you know, देखो electron, it donate electron from the nucleus, it donate electron to the nucleus, na? It donate electron to the nucleus. So it means it donate electron to the nucleus. It means the electron density of the nucleus is increases, na? Electron density increases in the case of plus M effect. Electron density increases in the case of plus M effect. Okay. Okay. Now देखो, minus charge, minus charge, minus charge. So plus M effect, electron density increases, especially in which position, you know, this is ortho and this is para. So now negative charge on which position, just check. There is a negative charge on ortho position, there is a negative charge on ortho position, there is a para position, there is a ortho position. Okay. Now in this case, how to draw this type of effect? So now just check. Oxygen donate 1 electron, yeah. So 1 electron, there is a formation of double bond. So the valency of oxygen and oxygen donate 1 electron, it means oxygen contain positive charge. Now it donate 1 electron, so it again donate 1 electron, there is a negative charge. So this negative charge, there's a one electron extra. It donate one electron, so there's a formation of double bond, and this is easily electron donate and to this side. Same for this, same for this. And now the first structure and the last structure, there's a delocalization of pi electron. देखो, just there's a different. In this case, there's a pi. There's a different, na. So this is a main resonance effect, and this explained by Kekulé. Okay, resonance structure explained by Kekulé. Okay, Kekulé is a scientist name. Now in this case, देखो, electron. Oxygen donate electron to the nucleus, so it means the electron density of nucleus is increases. Clear? And mainly in which position? Ortho and para position. The mesomeric effect are not applicable in meta position. Just learn. Clear? Negative charge, देखो, just there's a meta position, there's no negative charge on meta position. And same for minus M. देखो, it withdraw the electron from the nucleus. देखो, it withdraw the electron from the nucleus. देखो, ये अपने electron withdraw कर रहा है. तो now oxygen accept the electron. तो now in this case देखो, positive charge delocalization. In this case negative charge delocalization. In this case positive charge delocalization. It means electron density decreases. If atom contain positive charge, it means electron density decreases. And which position which has more effect? The electron density decreases, especially ortho and para. देखो again, ortho para. And now the first and last structure, there is a different pi bond in other position. देखो 1 2 3 1 2 3 and there is a 3 pi bond, but in different position. So mesomeric effect not applicable in meta position. Same for both. Okay, now there's a different type of question. Just check. Arrange in order of decreasing electron density in benzene ring. Okay, now you know there's a phenol. This is plus M effect. Electron density increases. You know there's a C triple bond N. So nitrogen is more electronegative. So it withdraw the electron from the nucleus. Okay, so देखो, withdraw the electron from the nucleus. In this case electron density to the nucleus. In this case electron density decreases. Yeah, and benzene have no effect. So you know plus M effect is more stable, and then C and then B, because in this case stability decreases, electron density decreases. It means stability decreases. So just you note down in your notebook how to check stability order. First plus M, then after hyperconjugation, okay, and then after plus I, then after minus I, and the last is minus M. So minus M is the last. Okay, and now just this is a stability order. Okay, now again, if you have acidic order, तो just opposite for stability. So minus M, then minus I, then plus I, then hyperconjugation, and then plus M. Clear? So this is a stability order and this is a acidic order. Clear? Now in this case, you know the plus M effect is more stable, so A, and minus M is a less stable, it means last, and C there is a no effect. Okay, now again in this case there is a 3 different example. So you know nitrogen have a 1 lone pair of electron, so it pushes the electron from to the nucleus, it means plus M effect. Okay, now in this case oxygen is more electronegative, so also minus effect is there, but plus M effect is more dominant to minus I. In this again plus M effect on oxygen again is a more electronegative, so minus I effect is also there, but plus M effect is more dominant to minus I effect. Same for this. Now except halogen is, in the case of halogen there is a different case. Okay, only case in halogen, in this case fluorine again donate 1 electron to the nucleus, and there is also fluorine is more electronegative than carbon, so there is also minus I effect. In this case electron density of ring decreases because of minus I effect is more dominant to plus M. Same for halogen, fluorine and chlorine. So in this case, minus I effect, not plus M effect, only for halogen. Okay, now again, decreasing order of electrophilic substitution, same. This is a same question, this is a stability order question. But the question name is different. Okay, now in this case, you know, there is a minus M effect, there is a minus I and there is a plus M. So in this case, plus M effect is more dominant, more stable than minus I, then yeah, clear. Same for there is a NO2 group, the NO2 is a minus M and minus I effect, both is there. Cn is a minus M, OH is a plus M and NH2 is a plus M. So now in this case, both are plus M effect. How to identify ki which has more stable? So this is the order. So देखो, in this case OH is the last and NH2 is the first. So NH2 order is the first. So first NH2, then OH, then what? There is a minus I effect also, B, and then here. Clear? So this is the order. The just you learned that this is the order of minus M and plus M effect. The same for this. देखो again, there is a CH2 negative charge. There is a CHO aldehyde group, Cl and OCS3. So there is a plus M, minus I and plus M. So just you learned ki which has more order. So then first is what? CH2 group is there. So this is the first. देखो, plus M effect, there is a first order CH2 minus. So this is the first, and then this, and then after C and then D. Yeah, same for this question. So just you practice this question. Okay. Now again, same for this. Why fluorine and chlorine? Which has more stable? So fluorine, there's a more electronegative. It means there's a more stable to chlorobenzene. Clear? Fluorobenzene has more electron density than chlorobenzene. Now acidic order, so you know the order is different. First you check minus M, then minus I, then plus I, then hyperconjugation, then plus M. Okay, in this case there is a, you know, again, if A minus is stable, it means acid is stable. Okay, now there is a different type of formula, COOH, COOH and COOH. In this case there is a no substituent NO2 and OH. So you know NO2 have minus M minus I and OH is a plus M effect and minus I. So minus I is less dominant and plus M is more dominant. So you know minus M effect is a more acidic, then A, then C, plus M is the last. Same for this. So just you practice this question. Okay. Same for this. In this case there is a minus, plus I, minus M and plus I. So plus M effect is more dominant. This is last, and the first is minus M, then minus I, then plus I, then yeah. Same for this. Acha, in this case there is a same group. You know very well meta positions, there is no effect, you know. Okay, in this case देखो, just you check ortho position in a first, then meta, then para. Okay, in this case meta position there is no reactivity of resonance. So C is first because in this case ortho position is near to CH3 group, but NO2 is a far. Okay, so now first is C, then A, then B. Because B and meta position there is a no mesomeric effect. Okay, same for this, just you practice. Okay, and now this is the last question. Same for देखो again. In this case there is a intramolecular hydrogen bonding, oxygen and hydrogen. There is a intramolecular hydrogen bonding. So it means intramolecular hydrogen bonding is there, so this is unstable. Okay, in this case there is a far, so A is first, then C, then B. B because there is no effect in meta position. So this is the full explanation of mesomeric effect. And now the next, my next video is a hyperconjugation. So first you practice these, then after hyperconjugation. Thank you and have a nice day.